curve along here. And H1 has a restricted domain, and that's that curve there. H3 is this curve here with a restricted domain, and H4 when we get to it, or H3 when we get to it, is this one here. And H is this. So the question's asking, state the maximal domain for H. Well, since we have a square root and the square root starts here or ends at 2, then the domain's going to be minus infinity to 2. If you thought there was a boundary and this graph finished here, I'd accept minus 5.5 through to 2, or whichever number similar to that. The rule for H1 is obtained by reflecting the graph of H in the vertical axis, so the y-axis. So reflect over the y-axis, replace x with minus x. So my rule, which used to be the square root of 2 minus x, now becomes the square root of 2 minus x. So x plus 2. If we want to go from H onto H2, H onto H2, then we have, it's a dilation by a factor of 2 from the x-axis, because this is my multiply by 2, and I'm going to translate 1 unit to the right, because I was at x 2 minus x, and I started here. I now go 1 to the right. I'm going to go 3 minus x. If I wanted to put that in mapping notation, I didn't dilate away from the x-axis, so that's going to be 1. I did move 1 to the right, so that's going to be 1. I did dilate by a factor of 2, so C will be 2. And I didn't do any translation, so D is equal to 0. Come up with the quadratic rule that has a stationary point at 4, 6 and passes through the point 2, 2. So I'm going to use the general rule, which is the turning point form, with a minus 4 here and a plus 6, and then put in the point 2, 2. And that can be done on calculator or by hand to give this particular answer. Find the domain of the inverse function of root 2 minus x. So y equals the square root of 2 minus x, but I'm going to make it 2 minus y and make that equal to x. So I'm doing the inverse, replace x with y. I'll select that interactive advanced solve to make it y equals, and there is my inverse minus x squared plus 2. And of course, the range of this was 0 to infinity, so the domain is going to be 0 to infinity. Check that this gives you H3. Well, if you make x equal to y plus 4, and you make y equal to x plus 4, we do a reflection over the y equals x line, and substituting, I do get the same answer, but the problem is I don't get the same domain, because this particular domain is 0 to infinity, and this particular domain is only 2 to 4. So technically, no, but yes, you do get the same rule, but you have a different domain. That's question number 4.